All right, we're going to begin chapter 3, section 3. I'm kind of going a little out of order here just because this lesson, you learn a lot of skills that are going to kind of lay the foundation for more involved problems, right? We're going to learn the skill of long division and synthetic division. Now you're going to see in this exact same chapter, this sort of division is going to have its uses when you get a question that says, for example, find the zeros of the polynomial, right? So then when we solve those kinds of problems, we're going to need to do long division or synthetic division, right? So that's why I'm kind of going out of order. I'm kind of doing this lesson first, and then I'm going back to do some of the other stuff, all right? So long division, there's a lot of steps here. It's going to be easier if I just show you guys, but it's going to look like the long division that you do with numbers, right? So if you know with numbers, let me do something pretty easy to start. So maybe like 4 divided by 23, right? 4 goes into 23 6 times, or I'm sorry, not 6 times, 5 times. Let's see, I already made a little mistake, but, and then 5 times 4 is 20, and then you have a remainder of 3, right? So then you get a remainder of 3, or you can say 5 3/4, or 5.75, right? But we're going to learn how to do this sort of division with polynomials. All right, so let me start with something fairly easy. In normal long division with numbers, you're going to set this up the same way. It's going to be your divisor, right? This number or term or expressions on the bottom. This is our divisor. And then this number up here, this is our dividend, right? And so we're going to set this up by putting our divisor on the outside, so x plus 1. And then underneath this little box sort of looking thing, it's going to be our dividend. So it's going to be x squared minus x minus 2. All right. And then what you do, similar to long division with numbers, is I'm going to take my divisor and I'm going to ask how many times or what do I need to multiply this by to get this first term in x squared, right? So think about it. The very smallest thing that you need to multiply x plus 1 by for an x squared to show up in that product is going to be just x, right? If you're wondering how I got x, well, think about it like this. If I do x times x plus 1, that's going to get you an x squared plus x, all right? And that's how you get what I just wrote in blue, right? So it's going to be x, this number up here, times this divisor right here, and that's going to get you this right here, right? And so the point of doing that is because now when you go to subtract, right, with regular long division with numbers, you would subtract this entire thing, right? And then when you go to subtract, it changes the sign of everything that you see. So it's going to become a minus x squared and a minus x. Now the point of doing this is so that this x squared and this minus x can cancel out, all right? So then every single time you're doing this, there shouldn't be anything in this little space right here. These should always cancel out, all right? And then this minus x and this minus x is going to make a minus 2x, all right? And so I can bring that negative 2 down here, and then we repeat the same process, right? You're going to ask yourself, what do I need to multiply x plus 1 by to get a negative 2x to show up in that product, right? And this time it's going to be a negative 2. Right, when I take negative 2 times our divisor, that's going to leave us with a negative 2x minus 2. All right, and then once again, you would repeat that process, right? This is going to turn into, right, once you subtract this whole thing, this is going to become a plus 2x and a plus 2. And so what always should happen is this negative 2x and this 2x should cancel. What sometimes will happen is that these are going to cancel as well, right? And then you're going to get a remainder of 0. If you have a remainder of 0, that's fine. It's just this here is going to be your quotient. So when you go ahead and divide this, this is going to get you x minus 2, right? Now, because this worked out in this way, another thing that you could have done was factor, right? Maybe you could have factored the top, and this would have gotten you, what would it get you? X minus 2. X plus 1, and then over x plus 1. And then you see that this x plus 1 and this x plus 1 cancel out, and then you're still left with an x minus 2, which is great if you know how to do that. If you were able to see that for this problem and you were able to cancel things out, and then get a simplified expression like that. That works great. But you're going to see in the next example, sometimes it's not going to fully cancel out. In this time, you're actually going to have a remainder, right? It's not going to go in perfectly. So then you could try to do the same thing. You could try to factor the top and try to cancel it with the bottom. But if it doesn't cancel, then you're just not going to be able to simplify it, right? So let's just try the exact same process. I'm going to take my divisor, put it on the outside. It's going to be an x plus 3. And then underneath that little box is going to be your dividend, the x squared minus x minus 2. And then once again, you're going to take your divisor and multiply it by something to get rid of this x squared up here. And it's going to be the exact same thing as it was before. I'm going to multiply this divisor by x, and that's going to get us an x squared plus 3x. All right, and then you would do the exact same thing as you did before. And then once you do this, you're going to subtract everything. All right, and then when you subtract everything, this should always cancel out. And then you get a negative x minus 3x is going to get you a negative 4x. Bring down the next term, and that's going to get us a minus 2. And then you repeat the process. You're going to ask yourself, what do I need to multiply x plus 3 by to get rid of this negative 4x? And that's going to be a negative 4. All right, and when I multiply this by negative 4, I get a negative 4x minus 12. All right, and then when you go to combine these, again, change the sign of everything because you're subtracting now. And then this 4x's are going to cancel out, and the negative 2 plus 12 is going to get you 10. All right, so we get a remainder of 10, but you're not going to leave your answer like this. You're actually going to write your answer as the quotient plus the remainder over the divisor. All right. If the words are confusing, that's fine. Your quotient is going to be this bit right here. So my answer is going to be x minus 4 plus my remainder is 10 over my divisor, which is what we divided by. It's going to be x plus 3. So this is how you're going to write your answer. All right. Now, there are a couple scenarios in which this is actually going to help us down the line. But again, for the sake of this lesson, we're just trying to teach you the skill of dividing polynomials. All right, so then we get slightly bigger ones, right? This is a good one to practice. All right, set it up the exact same way. I'm going to put my divisor on the outside, the x plus 2, my dividend on the inside of my box, and that's going to be a 5x to the power of 3 minus 6x squared minus 28x minus 2. And you're going to do the exact same thing as before, and you're going to ask yourself, what do I need to multiply the divisor x plus 2 by to get a 5x to the third? I'm for sure going to need a 5, right? And to get 3x's from 1x, I need 2x's. So I'm going to have a 5x squared, right? And I'm going to line them up, right? I didn't mention this before, but I'm going to line up. If it's an x squared, and you're going to see, especially with bigger ones, with bigger problems like this one, I would line up the degrees with each other. So if there's a square here, I would line it up here just to kind of keep it organized. And then, but once again, you would do 5x squared times x plus 2, and that's going to get you your 5x to the third, which is what you wanted. All right, and then 5x squared times 2 is going to get you a plus 10x squared. All right, and then once again, subtract everything. That's going to change all of your signs. And then what should always happen is these cancel out. All right, and then you're left with a negative 6x squared minus 10x squared, and that's going to get you a negative 16x squared. All right, next, bring down the next term, which is a negative 28x. All right, ask yourself the same thing. What do I need to multiply x plus 2 by to get a negative 16x squared? All right, and that's going to be a negative 16x, right? The negative 16 is going to give you that negative in front, and then the x is going to get you the x squared. And then when I do negative 16x times a positive 2, that's going to get me a negative 32x. All right. And then once again, just change the sign of everything that you just wrote down, and then that's going to have to cancel these out. All right. And then after I do that, I get a negative 28x plus 32x, which is a 4x. And then again, I would just bring down the next term, right? And this is the last term that we bring down here. And then once again, ask yourself, what do you need to multiply x plus 2 by to get a 4x? And that's going to get you a plus 4. Use a different color. All right, plus 4. All right, and so I can do 4 times x plus 2, and that's going to get me a 4x plus 8. But then once again, do the same thing and subtract, change your signs, and that's going to allow this 4 minus 4x to cancel out. And negative 2 minus 8 is going to get you a negative 10. All right, so this is our remainder. So this right here, this was our quotient. But that's not the only thing that we have in this problem. I still have my remainder of 10. So to write my final answer, it would be my quotient, 5x squared minus 16x plus 4. And then plus my remainder, which is negative 10, over my divisor, which is x plus 2. And then this is my final answer. All right? So hopefully the more you do these, the easier the process gets, right? That's really the core of the lesson is just that's how you divide polynomials, and later on we'll teach you another way. All right? So when you have something like this, right, this is the only other sort of special case that you might see is you're going to see that when you write this down the way that we did before, if I have an x plus 1 and then something like x to the third minus 1, you're going to want a space to write all of your terms, right? Because if I have an x to the third and then a minus 1, I'm not really going to have room up here to write the rest of my terms. And this is also something that's going to help you in the problems after this when we do synthetic division, is I'm going to want to have little placeholders, right? So I'm going to write over here little placeholders for my other degrees. So after 3, if you're going down, it's going to be a degree of x squared, or an exponent of 2, right? But if there's nothing in front, I would write a 0, right? 0x squared. You might be like, why are we doing this? You're going to see it's going to make a little bit more sense later on. And then I also don't see an x, so I'm going to write a 0x. After the exponent of 1, right, this had an exponent of 1, is just going to be our constant, which we do have. It's going to be minus 1. All right? So then now that I have that, I'll start the process. I'm going to ask, what do I need to multiply x plus 1 by to get an x to the third, and it's an x squared. All right? So hopefully you can see now I want to be able to line these up just so that it looks a little bit more organized, because then you might confuse yourself. You're not going to have room to write the rest of the stuff. And then when you go to bring down the next term, which I'm about to do, right, this is going to get you x to the third plus x squared, right? You want to make sure you're combining the correct terms. All right? So now that we did this, I'm going to go ahead and subtract and then cancel out everything that needs to cancel out. So those cancel out. 0x squared minus x squared is going to get you a negative x squared. And then once again, I would bring down the next term, which in this case is going to be 0x. And then ask yourself the same thing, what do I need to multiply x plus 1 by to get a negative x squared? And that's going to be a negative x. All right, and when you do negative x times x plus 1, and that's going to get you a negative x squared minus x. Do the exact same thing, change all your signs. And then this x squared and this x squared should cancel out, and we should be left with an x. Bring down the last term, and it's going to be an x minus 1. And then do the same thing, right? What do you need to multiply x plus 1 by to see an x? And it's just a 1, right? These x's already match, so I just need to multiply by 1 to keep them matching, right? So it's going to be an x plus 1 right here. Once again, subtract, change your signs, and that's going to cancel out these x's, and you're left with a negative 1 minus 1, which is negative 2. And then once again, your answer, this is your quotient up here, right? That's your quotient. But I need to have my remainder accounted for. So I'm going to have plus my remainder of negative 2 over my divisor. And then this right here, this is your final answer. All right, so synthetic division is the one thing that's probably new to you guys, right? This hasn't been done in any other classes, and there's no other application of this that I can relate. Just like long division we did with numbers in elementary school, I don't think there was an application for synthetic division, right? So this is probably the first time that many of you are seeing this. Again, the steps are in words that might be a little confusing. You're going to have to see it to be able to fully do it. But one of the biggest things for synthetic division is that you need to have your divisor. It needs to look something like x minus c, right? Where c is a constant. And then you're going to write your c value, right, to the side of it, right? But that's the biggest thing. If I had, let's say, an x squared minus 5 as the divisor, I wouldn't be able to do synthetic division. I would have to use long division, right? So it only works if I had, let's say, x plus 1 as my divisor, or maybe like an x minus 3 as the divisor, right? But anything with a higher exponent, and even with a number in front, like let's say I had like 4x minus 3, right? There is a way to get it with, there is a way to figure out what constant to put in your synthetic division, but it's not going to be just the last one, right? But again, it should look like x plus a number or x minus a number, right? And you're going to see how that works in the next slide. All right, so we had already kind of done this example before with long division, but I'll show you exactly what it's going to look like in synthetic division. So what's going to go in your synthetic division, the setup for this, some people do it differently. I make a little box up in the corner, and then I just draw a line like this. What goes in this box, all right, let me highlight. What goes in this box is going to be your C value, right? So your divisor should be written in x minus c form. To get an x minus c form from x plus 1, keep in mind this is the same as x minus negative 1. All right, so that means my c value is negative 1. So that's what I'm going to put in this little box up here, negative 1. And then what's going to go here right beside it is going to be the coefficients of your dividend, right? Just the coefficients in decreasing exponent order, right? So you're always going to start with your x squared term, your x term, and then your constant term, and then your constant, right? So then the coefficient in front of x squared, I don't see a number in front, so I'm going to assume it's a 1. And the coefficient in front of my x term is going to be a negative 1, and then my constant is going to be negative 2. All right? And then it follows this algorithm, right, which is going to look like this. The first time, you're going to bring this number down. You're not going to do anything to it. It's going to stay a 1. And then a number that goes up here, right, is going to be this number down here times our C value, right? And our C value here is negative 1. And 1 times negative 1 is negative 1. And then when you do negative 1 minus 1, this is going to get you a negative 2. And then you, oh, I didn't even mention that, right? Here going vertically, right? So here, you're going to add, right? So negative 1 plus negative 1 is going to get you a negative 2. So vertically, you're going to add, and then diagonally up, you're going to multiply, right? So then from here, this negative 2 to get to this spot, I'm going to have to multiply by that negative 1. So to go from negative 2 up here, this is going to be negative 2 times negative 1, which is a positive 2. And then once again, vertically, you're going to add. So negative 2 plus 2 is going to get you a 0. All right? Now, you're probably like, why did we do that? What does all this mean, right? I don't, like, maybe you just don't know what these numbers mean. These are going to be the coefficients of your quotient. Coefficients of your quotient. And then this right here, this is going to be your remainder. Whoa, that looks bad. Remainder, right? So this 0 means that we have a remainder of 0, right? There is no remainder in this case. And the coefficients of your quotient is always going to be 1 degree less than your original dividend, right? So if I had an x squared up here, then this coefficient, this 1, is going to be the coefficient of an x term, right? Without the x squared. So this is going to be a 1x. And then this right here, this minus 2 is going to be your constant. So really, we just have a 1x minus 2, so our answer is just x minus 2. All right? Might be a little strange just because, again, this is new. You guys haven't seen it before. But I promise, the more that you do them, it's going to be easier. All right, so let's try another one. This is another one that we did earlier, right? And you might have noticed, number 5, example number 5, we actually did. That was our first example of this lesson, and it was using long division, right? But again, I'm going to do this one using synthetic division. Again, I'm going to set it up. I'm going to have my box and draw the line. In this box goes your C value. So this is going to be x minus negative 3. So that means in this little box should go a negative 3. Again, you just do the opposite of the sign that you see. All right, so it's going to be a negative 3 in that box. And then up here is going to go the coefficients of your quotient. All right, so the coefficients of our quotient here, of our, I'm sorry, not our quotient, our dividend is going to be a 1, right? It's a 1x squared minus a 1, right? Negative 1 minus a 2, right? So it's going to be minus 2. Exact same as the last one. So then I'm going to go ahead and bring down that 1. Again, that first number you bring down, it remains untouched. What goes up here is going to be that number times the number in your box, right? And the number in your box is a negative 3. 1 times negative 3 is negative 3. And negative 1 minus 3 is going to get you negative 4. And then again, going diagonally, you multiply negative 4 times 3 is going to get you a positive 12. And negative 2 plus 12 is 10. And there's nothing left to do here. You're just going to write your answer. Again, this is the coefficients of your quotients, and then this is your remainder. All right. Now to write your answer, again, your highest exponent in your dividend was a squared. So that means the highest exponent of your quotient is going to be just an x to the power of 1, so just x. So that means our quotient is an x minus 4. And then our remainder of 10, again, it's going to be exactly the same as it was in long division. So I'm going to do a plus 10 over x plus 3, right? Our remainder over your divisor. And then that's how you would write your answer. All right, now let's try the exact same thing with this one, right? Hopefully this one is going to be a little bit clearer than some of the other ones, right? If you still don't get it, right, you're going to see it's going to hopefully make a little bit more sense. Again, set it up. I'm going to have a box and then draw a line. And then in this box is going to go your c value. If it's an x plus 2, again, this is the same as x minus negative 2, so I'm going to have a negative 2 in that corner. Another thing that you could do is just set the bottom equal to 0, right? X plus 2 equals 0. And then when you solve it, right, minus 2, you get x is negative 2, and that's the number that you're putting in that box, all right? And then once again, right beside it is going to go the coefficients of your dividend. All right, and your dividend is the number on top, or the expression on top, in decreasing exponent order. So in front of the x to the third is a 5. In front of the x squared is a negative 6. In front of the x is a negative 28. And the constant is negative 2. All right, so this should be our setup. And again, I'm just going to bring that number down, the first one. You don't do anything to it, so 5. And then what goes up here is you multiply that number times the number in the box. So 5 times negative 2 is a negative 10. And the negative 6 minus 10 is a negative 16. And then do the same thing. Multiply negative 16 times negative 2 is a 32. And negative 28 plus 32 is 4. Again, bring that number up top. It's going to be 4 times negative 2, so negative 8. And when you do negative 2 minus 8, that's going to get you a negative 10. And then once again, these are going to be your coefficients of your quotient, and then this last number here is going to be your remainder. All right? And because our highest exponent to start was a 3, that means my highest exponent in our quotient is going to be an x squared. And then it's going to go again in decreasing exponent order. So it's going to be an x squared minus 16x plus a 4, and then this negative 10 is your remainder. So your answer, your final answer, is going to be a 5x squared minus 16x plus 4 plus negative 10 over your divisor, so over x plus 2. And then that's your final answer. And again, you can confirm that this is true based on what we did in example number 3. All right, should get the exact same thing. All right, and I'll do the exact same thing with this one. And this is going to be slightly different just because, again, the process, when you have higher exponents, you're going to need to account for those missing exponents, right? So again, you can set your bottom equal to 0, and then we get x equals negative 1, and that's the number that goes in your box. Or you can think of it like x minus negative 1, and that's your c value. That's what's going to go in your box. And then right beside it is going to go the coefficients of your dividend, right? So this is going to be a 1x to the third, right? And I'm not just going to go 1 with a minus 1 because that's what you see here, right? You need to account for all of your exponents, right? So remember, up top, this is an x to the third. We need a spot for an x squared, I need a spot for an x, and I need a spot for the constant. If I don't see an x squared, I just need to have a 0 there as a placeholder, because if you don't have that placeholder in synthetic division, you're going to get your answer completely wrong, right? A lot of times when I see kids getting mistakes, they ask me, why am I getting the wrong answer, right? I told them, check and make sure that you're accounting for all of your exponents. And so you get a 0 with the x squared. I don't see an x term either, so I need another 0 there. My constant term is this -1, right? And you're going to see when we do our process that that's going to, right, it's going to really affect our answer. So I'm going to bring down that 1, right? Again, the first number remains unchanged. Up here is going to be 1 times -1, which is -1. 0 minus 1 is -1, and -1 times -1 is a +1. 0 plus 1 is 1, times -1 is -1, and then you add -1 and -1, and you get a -2. All right? And so these, once again, these are going to be the coefficients of your quotient, and then this is going to be your remainder. All right? So then our answer, again, because I have an x to the third as my highest exponent, this is going to be an x squared minus 1x plus a 1, and then this is going to be your remainder, which is over your divisor, right? So my final answer is going to be x squared minus x plus 1 plus -2 over x plus 1. And then that is your full quotient, all right? Now let's just say you made a mistake and you didn't have that placeholder. I'm going to do it off to the side, right? Don't write this down, but I'll have off to the side. -1, you do a 1, and then a -1, and then you just go to bring this down. And then a 1, you get a -1, and you get a -2, right? And then this would be your answer. You're saying that this is your quotient, which by the same logic that we've been doing would be an x squared, and then you would have a remainder of -2. So plus -2 over x plus 1. And do you guys see that that answer is completely different than the actual answer, right? This right here, all right? So you need to be really careful, right? When you have little missing exponents in your dividend, you need to account for those, because otherwise you will get the answer completely wrong, right? So let me erase that, right? And then again, this should be the actual final answer. All right, now this is something that looks a lot bigger. It looks pretty intense. But again, this is something that you cannot use synthetic division for, just because the denominator is not written in the form of x minus c, right? We have an x squared, all right? So this is one that you actually have to use long division with, right? So it's going to look really tedious, but again, it's going to be the exact same process as always. So I'm going to have my divisor on the outside, and then my dividend on the inside. All right, so just give me a minute while I write this down. All right, and then what we're going to do is we're going to need to ask ourselves, what do we need to multiply this expression by to get a 2x to the fourth, right? And it's going to be a 2x squared. So I'm going to line that up with the x squared right there, and then when I multiply this expression by 2x squared, I get a 2x to the fourth plus 4x to the third minus 6x squared. And then again, change the sign of everything because you're subtracting. And then you get that this cancels out. And you also get that the x to the third cancels out, right? That doesn't always happen, but it did in this case, right? And then you're going to do a 5x squared plus 6x squared. I'm sorry, a negative 5x squared plus 6x squared, and that's going to get you an x squared. And then bring down the 3x, all right? Because there are 3 terms here, I would bring down both of them. So I would actually also bring down that -2. All right, just to account for every single term, right? But then you would do the same thing, right? What do you need to multiply x squared by to get an x squared? And it's really nothing, right? You can just multiply a 1. So I'm just going to do a plus 1 up here, and that's going to get me an x squared plus 2x minus 3. All right, but then you can subtract everything. And then that's going to cancel this out. 3x minus 2x is going to get you an x, and then -2 plus 3 is going to get you plus 1. So that means your remainder is x plus 1. So then this right here is your quotient. So I'm going to write my final answer as 2x squared plus 1. And then plus my remainder is going to be the x plus 1 over my divisor, which is x squared plus 2x minus 3. And then that would be your final answer. Again, can't use synthetic with this one. You have to use long. But even when your expressions are bigger, right, it's still the same process. You just need to be careful with your work, right? Make sure you're doing your signs correctly. Make sure you're not missing any negatives or positives anywhere. All right. The remainder theorem is one way that we can evaluate functions, right? So let's say I have a really big polynomial and I want to find like f of 5, for example, right? You guys know that as you would plug in 5 everywhere that you see the x. But another thing that you could do is you could use synthetic division to get your answer maybe sometimes a little bit quicker, right? So I'll show you what that means. Right, so if I want to find f of negative 2, all right, then what I would do is, in some instances, you can just plug in negative 2 everywhere that you see the x, but you're going to see that that might be a little bit troublesome, right? This is going to be kind of a lot like bigger of a problem, right? It's going to give you big numbers to simplify and whatnot. So I'm going to use synthetic division instead. I'm going to use this number, right? Keep in mind, the number inside of here is already your c value, so you don't need to change the sign like we did before. I'm just going to throw that negative 2 in the box, and then right beside it is going to be the coefficients of my polynomial. So 3, an 8, a 5, and a negative 7, right? I'm not missing anything, right? Because the exponents are 3, 2, 1, and then my constant. So I'm not missing anything. I don't need any zeros as placeholders, so I would just do synthetic division, right? Bring down the 3, and 3 times negative 2 is negative 6. 8 minus 6 is 2, times negative 2 is negative 4, 5 minus 4 is a 1, and 1 times negative 2 is negative 2, and then you get a negative 9. What we mean with remainder theorem is that when I plug in negative 2, I should get negative 9 as the answer, right? So what does this mean? This just means f of negative 2 is equal to negative 9, right? And you can verify this if you want to, right? And you can do 3 times negative 2 to the third plus 8 times negative 2 squared plus 5 times negative 2 minus 7. And you can simplify that whole thing, and you can verify that that does get you negative 9. I'm not going to do it in this video just because, like I said, it's going to take a little bit more work than just doing synthetic division, right? Maybe not that much work, right? It shouldn't, like, this is something that I do expect you guys to know how to do, but in some problems, right, you can just use synthetic division to evaluate your functions a little bit better, right? A little bit faster. All right, so f of negative 2 is negative 9. And we can do the same thing with this one, right? Plug in 4. All right, so when you plug in 4, you should get a 4, a 10, a negative 3, and a negative 8. All right, so again, 4 goes in your box. Right beside it are the coefficients. And again, nothing is missing here. I have all my exponents, 3, 2, 1, my constant. So then I'm just going to use synthetic division to evaluate f of 4, right? We're going to figure out what this is in a second. So bring down the 4. 4 times 4 is 16. And then 10 plus 16 is 26. When you do 26 times 4, you should get 104. You can verify that if you need to. And negative 3 plus this is 101. And 4 times 101 is 404. And then negative 8 plus 404 is 396. All right, so maybe you did need to do a little bit of work off to the side if you didn't know some of these computations off the top of your head. But you can see that it might be a little bit faster than if you were to have done 4 times 4 to the third power plus 10 times 4 to the second power, and so on and so on. All right, so your answer is your remainder, right? I don't need to worry about any of these because the question's just asking to find f of 4, right? I don't need to do anything else, anything other than that. All right, factor theorem states something similar to what the remainder theorem says, and it's the same thing where if you plug in something, you're trying to test what number you get out of it, right? And if you get a remainder of 0, then that means you have x minus k or x minus c, right, which is what the letter that I was using before. That means you have that as a factor, all right? And then once you have that, you already know what one of your solutions of your polynomial is. Then, like, let's say I ask you guys, find the zeros of the polynomial, and it doesn't factor at all, then this is what you would have to do, right? You would have to use one of the factors that we give you, and then you have to solve whatever's left over, right? And I'll show you what that means. All right, so I've given you guys this polynomial, and I want you guys to determine if x minus 2 is a factor, right? So let me just write this down. X minus 2 is a factor if if the remainder equals 0, right? So if I do my synthetic division and I get a remainder of 0, then that means x minus 2 is a factor, right? And remember that this is in the form of x minus k or x minus c, and then in the box is going to go your k value, which in this case is 2, right? Again, use x minus 2 equals 0, and then you get x equals 2. That's the number that you're putting in that box, all right? And then right beside it is going to go the coefficients of your quotient. So it's going to be 2, 7, -4, -27, and -18. And let's just see if this works, right? I'm going to bring down 2. 2 times 2 is 4. 4 plus 7 is 11. Times 2 is 22. Minus 4 is 18. Times 2 is 36. Minus 27 is 9. And times 2 is 18. And -18 plus 18 is 0. Right? So we get a remainder of 0, right? And if our remainder is 0, then I would say yes, x minus 2 is a factor. All right. For the sake of this problem, that's all that we were asked, so I'm just going to say that this is a factor. Some other ways that you might see this problem is to find all the zeros. Then you would have to set your quotient equal to 0 and then find the rest of your zeros, which we'll do in the next slide. But I'll do the same thing here. I'm going to determine if x plus 3 is a factor. Again, when I do x plus 3 equals 0, I get x equals -3. And that's what I'm going to put in that little box. And then I'm going to set it up the same way, right? 2, 7, -4, -27, and -18. All right, bring down the 2. -6 is 1, times -3 is -3, plus -4 is -7. I get a positive 21 here, and that's a -6. All right, and then I get a 18. All right, and that does work, right? I do get a remainder of 0, so I'm going to say yes, x plus 3 is a factor. All right, so then that would be my answer to this problem. All right, that's all we were being asked. We get a remainder of 0, so I know that this is a factor and that this is going to give us a nice quotient without a remainder. All right, this is the last sort of problem that you might see in this particular lesson, and we're telling you that x plus 3 is a factor, right? So what does that mean? If I'm giving you that this is a factor, you should expect that when you do your long and synthetic division, that you get a remainder of 0. Then I'm telling you to find all of your factors or zeros, right? And I'll show you how to do that, right? So again, x plus 3 equals 0. We get x equals -3. So then what we know for sure is that if this is a factor, I know that one of my answers is x equals -3, right? That means the same thing as if I have a factor of x plus 3. So I'm going to use that number, -3, and I'm going to use synthetic division. So then my first number is going to be 1, right? And hopefully some of you can recognize, right, what should go next to 1, right? You should say 0, right? Why 0? Because I need a placeholder if I don't see an x squared, right? I have an x to the third. I don't see an x squared, so I'm going to say that this is plus 0x squared, right? And then I do have an x, so I'm going to do a -19 and then a -30, all right? So I'm going to bring down that 1 and then do synthetic division, right? So we are expecting 0 out of this, right? So you're going to see. All right, so we did our synthetic division. I did get 0, right? And what does that mean? That just means that this right here is the quotient. And then our answer to this is going to be an x squared minus 3x minus 10. All right, so that's our quotient after we divided, right? How do I know that? Because my original problem had an x to the third. So then my quotient is going to be 1 degree less. And then if I want to find all of the zeros and the factors, then I'm going to set this equal to 0 and solve. Right, so x squared minus 3x minus 10 is going to factor as x minus 5 and x plus 2. Right, so these are my factors, right? And I'll write that off to the side. Let's say on the quiz or test I asked you to find all of the factors. All of my factors are x plus 3 because that's what we were given. Right, x minus 5 and x plus 2 because that's what we just found. Right, and now let's find our zeros. Our zeros, we already know that x equals -3 is one of them. Right, now I need to find the rest. So I'm going to set these equal to 0, and I get x minus 5 equals 0. and x plus 2 equals 0, and so I get x equals 5 and x equals negative 2. So my zeros are negative 3, 5, and negative 2. All right. So kind of a longer lesson. We kind of cover a lot of different skills, right? The biggest one being that you need to know how to use synthetic division, right? We don't use long division super frequently in this course. What you're going to see a lot is synthetic division. And it's a good skill to have because in the section after this, we're going to have to do synthetic division sometimes like 3 or 4 times in a single problem. All right. And so it's a good skill to have, and it's something it's a skill to sharpen, because the quicker you're able to do it, right, the better you'll be at some later lessons, right? So this is just a skill that we're going to use. As you can see, it has its applications, right? This is an example of a problem that you might see, right, on like a test or a quiz, right, where we ask you to find all of the information.